And I welcome back to this video series, which is called Ramblings of Ramblings of us about nuclear technology by a Singaporean. Okay, so welcome back. How's everybody? Yeah, um, you can answer that obviously. It's just a way. Yeah, I'm just used to talking like that. Okay, let's get started. Yeah, so in the last video, we talked about how nuclear technology has influenced pop culture. Yeah, so I'm just gonna briefly try and get through more of that, and especially talk a little bit more about nuclear technology or nuclear weaponry and the Cold War, which is point number two. Before we get to the more sciencey stuff, because that's where things were interesting. And of course, the Cold War has actually influenced a lot of pop culture as well, a lot of games. Yeah, so let's. I'm going to just wing it, meaning to say I'll just speak from memory. I'm just going to ramble. If there are references, I might leave that to a future video. So I may not have 100% good memory on this, so don't mind me. But I may include some references later on. So let's talk about the Cold War and nuclear security. Okay, of course, Cold War will lead into things like Chernobyl. Okay, because Chernobyl is a Russian reactor called the RBMK, um, and yeah, there is some connection between the RBMK type reactors and economics and maybe even weapons manufacturing. Okay, so all of these reactors, weapons, these are the reasons why nuclear technology was studied in the past. So let's go to the backstory first. Okay, now let's start with 1945. This is post World War II. 1945, we have two times atomic bombs. Okay, and they came by plane. Okay, they came by plane. I can't remember. Only remember one of them is called the Enola Gay that dropped Little Boy. I cannot remember Fat Man's plane that dropped the bomb on Nagasaki. Yeah, but that's how the era of nuclear weapons started. And from 1945 onwards, 1949, I believe US is the only major nuclear power, if not the only one. Okay, I'll just put only over here. Only major nuclear power. And 1949, if I remember correctly, the Soviets actually, so the Soviets actually explode their first nuclear device called Joe 1 in 1949. Again, I do not remember the exact dates. Okay, you can search that online. Here's the Wikipedia page, which you can take a look later. Okay, well, I'll just try to go on the drawings from memory. So, USSR, Soviet Union, in other words, explodes first atomic bomb. Okay, so now you have a problem where you have two nuclear states. This is for most of the Cold War. Just going to draw two randomly shaped countries. Okay, Russia is supposed to be more elongated. The US, okay, it's supposed to be like that. This is Alaska. This is the West Coast, and so on. Canada is somewhere here. I'm going to draw it really ugly, and then this is the USSR. Okay, USA. Uh, uh, Pardon me, my drawing is very bad. Okay, here's Florida. Okay, and yeah, I'll just leave it as that. Now, these two countries, I think they are separated by 6,000 to 8,000 miles of Atlantic Ocean. You can go and check the figures, but it is really far. I think it's a 8-hour flight also by today's jet liners. Atlantic Ocean. Okay, so Well, you have nuclear weapons. At this time they are mostly going to be bombs. Okay, I'm just going to draw it like that. Okay, nuclear bombs mainly. All right, so the question is, all right, you want to have these on standby, okay? And the old doctrine of war, the old doctrine of war is to cause as much damage as possible. So what they have is this big fleet of bombers. Okay, I'm just going to draw a very lousy bomber plane. Okay, very lousy bomber plane. Uh, so these planes will actually carry nuclear bombs, right? They will carry nuclear bombs in their payload. All right, and right. So let's just say you put an airfield here that is having some of these bombers on standby, which can fly over to the Soviet Union and drop their weapons. Okay. Likewise, the Soviet Union, they're going to have their own set of airfields as well, and they're going to have their own planes. Okay, I'm just going to use red because the Soviet Union flags are red colored. So, yeah, a communist country. Okay, so a lot of the time is a red colored flag. So I'm just going to use this red colored plane to denote that, hey, this is a Soviet plane. Okay, so you have these two countries with nuclear bombers on each side. Okay, so the military guys would think, okay, um, if there is some kind of emergency, okay, if there's some kind of emergency that you need to use nuclear weapons, okay, and of course these two countries are quite vehemently opposed to each other during the Cold War, except that this war did not become a actual war, thankfully. Okay, but let's say it did. Okay, this is how the military guys would think, or somewhat, just to give you a sneak preview. Okay, I want to send my planes over to the USSR to bomb them. Okay, but being a military guy, you would also have to plan for contingencies. Okay, what kind of contingencies, right? Obviously, the USSR is not going to be so stupid as to just let you come into their front door and drop nuclear weapons. Okay, what will they have? Okay, they will have this thing called air defenses. Okay, surface to air missiles, or most of the time during this era, we will be flak, I believe. Okay, flak. Okay. Likewise, the US is going to have its own flag, okay, or anti-air artillery. So I'm just going to draw these. It's going to have its flag as well. All right. So what will you be thinking as USA? Okay. If you are on the US side, you will say, okay, Soviet Union's gonna have flag. I'm not gonna have 100% of my bombers make it through and drop bombs on every city. Okay, that's the way of military thinking, and it's a very unfortunate way because you're dropping bombs on cities, and this is called strategic bombing. In nuclear security terms, we call this counter value. Okay, counter value. All right, so you basically drop bombs on cities. Okay, yeah, counter values to drop bomb on cities. Okay, so for counter value play, you have many bombs, or you have maybe, let's say you have one bomber for each city, but you're going to anticipate that your enemy is having flag. So what do? Okay, you come up with contingencies. Instead of having one bomber per city, maybe let's have 3 to 5. All right, 3 to 5 bombers per city to get rid of this flag problem. Okay, so and then these guys will have to so-called overwhelm the air defenses, and you hope you have enough of them so that if USSR tries to do anything against the US, you have sort of a ability to strike back and strike back hard. Now USSR is going to think of the same way as well. So these guys are going to have maybe 3 to 5 bombers for every US city because you have to account for flag. Now, number two, let's say you have these airfields. All right. You have flag. Okay, there will be fighters as well. Fighter planes or even fighter jets by this era. Okay, and these are designed to shoot down bombers, obviously. So of course, this 3 to 5 times is going to account for the fighters as well. I'm just giving you random numbers. Now, what happens if let's say you use this bomber and you want to you be a bit more humane. You want to be a bit more humane. And how do you be more humane? Instead of diverting the bombers to the cities themselves, rather than going for the cities, you divert the bombers to take out the aircraft while they are still on the ground. Okay, you take out their airbase. So you use nuclear weaponry to take out your opponent's nuclear capabilities. Okay, this concept in the Cold War is called counterforce. Okay, you can read about it in books such as Wizards of Armageddon. I did take a class on that. But okay, so this thing to drop bombs to kill opponents' nuclear capability. All right, nuclear capability. Okay, so these are the two big ideas that you kind of have to know when you talk about nuclear deterrence. How do you use your nuclear weapons? Do you want to drop them on cities, or do you want to be a little bit more humane and drop them on your opponent's air bases that have these nuclear bomb storage? Okay, so maybe instead of 3 to 5 times, you want to have some bombers on standby for every airbase. So instead of 3 to 5 times, let's say 20 times, yeah, 20 bombers. So you want to have some for the airbase, you want to have some for each city. So you can see this this thing actually has escalated into an arms race. So if you ever wonder why we have so many, we can destroy. There are enough nuclear weapons to wipe the world. All the world cities many times over. This is the reason. Okay, it's all this military planning. Okay, and that boils down to that. Now you have this bomber situation, and then you kind of have an open airfield that's very open to attack. You can use nuclear weapons, or you can even use conventional weapons. So even normal bombs, you don't have to use nuclear bombs. Okay, you can even use normal bombs and missiles to take out your opponent's airfields and bomb storage, right? So what happens? What happens is that instead of you just having airfields, okay, your second best bet is going to be underground missile silos. Okay, underground missile silos. Okay. So what happens is that your missiles, they'll be stored underground. Okay, not just for protection, but to avoid detection in the first place. Okay, so there's the missile silo. Okay, if you ever see the Red Alert 2 series, Red Alert 2 or Red Alert, these are the old games. Okay, they do talk about these missile silos, and especially in Red Alert, I think the missile silos are actually underground. The idea is to conceal it from the enemy so that you cannot actually find out where all of them are. Okay, you cannot find out where all of them are, so you don't reveal yourself. And these guys are a little bit harder to destroy than say the airfield, and you have your nuclear weapon arsenal above ground. You're asking for an attack. Okay, if you're gonna wipe this out so easily using a nuclear weapon, why not store these nuclear weapons underground? And then instead of having planes that you can shoot down, okay, what you do is you have nuclear missiles. Okay, we deliver them in this device called the intercontinental ballistic missile. Okay, otherwise known as ICBM. Okay, all this is public domain knowledge. Okay, so so the idea of the ICBM is that, hey, you cannot even shoot down. Since you can shoot down the airplanes, why not give you missiles which are way harder to shoot down? Okay, so this is what we call arms race. So first we have planes, then we have these ICBMs. And the thing is how they work, okay, how they work. So you have these missile silos here, and let's say this is the edge of your atmosphere. Okay, so what you do is you literally launch your missiles up across the atmosphere. So your missiles, the job of the missile is just to send it up to the atmosphere, and then maybe the bomb is at the tip or something like that. Okay, so your bomb is here. Okay, and these things will actually literally go into orbit. Okay, orbit, or just a little bit below orbit, and they will orbit at a crazy high speed. And then you kind of want them to get back into the atmosphere, and you literally fall using the force of gravity, and you will hit your target here. Okay, let's just say X is this target. Okay, so the idea where it enters orbit and falls using gravity. Okay, so this is called a ballistic trajectory. So basically, there are no rockets at this point. There are no rockets. It just falls in gravity, and you kind of guide your way back to the target. So the reason why it's called a ballistic missile, I think I might need to check my spelling. Okay, the reason it's called ballistic missile is not because it's a big boom and everything. No, it's actually based on physics. It actually follows a trajectory to the target. Okay, so that's what a ballistic missile does. And the why is called intercontinental. The picture here does show it. You actually cross from the North American continent to the Asia/Europe continent. Okay, so these are ways you can sort of so-called outplay your opponent. Now, of course, the Soviets, they were smart as well. They start having their own ICBMs. Okay, so they start having their own silos and ICBMs. Okay, so some of these may be stored underground, and these will be harder to detect and harder to destroy, even with conventional nuclear weapons. Or you have to spend a lot of ground forces to get to these missile silos. And if you're going to use a lot of conventional ground forces or even air forces to destroy these silos, it may be too late. Okay, some of these missiles may already be launched out of some of these silos may have already launched their nuclear missiles, and by then it's too late. The damage is already done. Okay, so the idea is you want to destroy these nuclear missile silos before they have a chance to launch. Okay, so this is our story of the arms race. Okay, so well, the thing is that with missile silos, it's very easy to detect. They are stationary, and the idea is that, okay, if it's going to be a stationary, it's going to be a sitting duck, right? If it's going to be a sitting duck, then maybe these missile silos will not function as well if you want to use them to deter your opponent from attacking you. So what do you do? Okay, sometimes you have mobile missile launchers. Okay, let's say you have these mobile missile launchers. You might have seen this on some of the parades. Okay, so there's this big ICBM, and they will be hoisted on some sort of a launcher. Okay, they'll be hoisted on some form of a launcher, and the idea is that you want to have them drive around so that they're never in one place at any time. Okay, so this is a mobile, like a mobile ICBM kind of thing. So this is actually, it improves the ability of the ICBM to actually provide some military deterrence, or in this idea we like to call nuclear deterrence. You want to give as much disincentive as possible for your opponents to attack you, because if they do, you can actually strike back. So this idea is called nuclear deterrence. Okay. Now you of course never want to actually launch your nuclear weapons in this case, but the threat of it is supposed to prevent any escalation of war. That's the whole nuclear deterrence doctrine. So, all right. So, what do we have here? We have aeroplanes. We have missile silos. Okay, and you have mobile missile silos as well, or mobile ICBMs. Okay, but these guys are still they are still above ground. You can actually find them out using spy satellites or spy planes. A lot of Cold War has to do with spy planes like the SR-71 Blackbird. Okay, so this is one of the spy plane. I think there's a U-2 spy plane. These are all Cold War era spy planes. The idea is that you want to get as much intelligence as possible about your opponent's nuclear arsenal. So you can take them out, hopefully, if you need. But the idea is that you have so many of them spread over the whole country. Yeah, you spread them out over the whole country so that any attempt to even take one of these out will cause the rest of the missiles to launch. Okay, or rather, if USA attacks one of Russia's nuclear missile silos, then maybe you have 50 other silos that will just start launching missiles at the USA. Right, so that's the whole idea. You never want to start this thing off, and that's called mutually assured destruction, or MAD. Okay, MAD. So this idea of mutually assured destruction is supposed to prevent any escalation of war. Okay, it's supposed to prevent any escalation of war because there's a strong deterrent on either side, from actually which prevents them from actually launching any form of nuclear attack against the other country in the first place, because that will spell doom for both countries. Okay, that's the idea of mutually assured destruction. Now, the thing about this deterrence is that, okay, all of these airplanes, missile silos, these are vulnerable because they are situated on land. They are for the most part they are fixed. They are vulnerable to attack. So, what then is a strategy that can prevent this from happening? Okay, so you may have watched a lot of Cold War movies, and those are submarine movies. A lot of Cold War submarine movies, right? So let's draw a submarine here again. Okay, submarine movies. There you go. Let's put it. No, that doesn't look nice. Yeah, so these submarines will be like Crimson Tide. Movies will be like Crimson Tide and Hunt for the Red October. The idea is that you actually house your nuclear missiles in here, inside the submarine. Okay, you house your nuclear missiles inside the submarine, and these guys will be roaming, let's say what, in the Atlantic Ocean 24/7 or 6 months at a time, and we call this submarine launched ballistic missiles. Submarine launched ballistic missiles. Okay, submarine launched ballistic missiles are called SLBMs. Okay, so now the problem, I mean, this is all great and all. This is great and all, but why did we not have them in, let's say, 1949? Okay, why didn't we have them in 1949? Okay, so the submarine launched ballistic missile concept, it requires two sorts of technologies to make it effective. Okay, because yeah, you have to stay underwater for very long. That's one. So so this is the needs of having submarine launched ballistic missiles. You need to stay underwater very long, never surface. Okay, very long. Okay. Number two. Okay. You imagine. Remember. Okay. for a ballistic missile to work, you need to kind of guide these ballistic missiles, these warheads, okay, because they are usually at the head of the missile, okay, if I'm not wrong. Okay, I never touched these before, so I'm just guessing based on the name. You can go and search and correct me later on. Okay, the thing with ballistic missiles is that if you have a nuclear bomb, you kind of want it to be accurate enough to hit the target. Okay, so and that itself is already a challenge. You want to have a fair degree of accuracy to ensure the bomb hits the target so that you do not waste your weapon. Otherwise, you will just have to launch maybe 10 bombs and hope one of them hits the target. Okay, that's quantity over quality. Right, so accuracy is important for these kind of bombs. Yeah, you want to generally hit them within 1 kilometer to 5 kilometers because the blast radius of a nuclear weapon, while big, okay, it's not that big. Okay, so let's say you want to have it within 1 km or even maybe a few hundred meters, 500 meters. Huh? So this for a smaller nuclear weapon. You want to have this within maybe, I don't know, this much, right? And this accuracy thing is actually a lot trickier with a submarine launched ballistic missile because first thing, you're underwater. Second thing, you are space constrained. So accuracy is a big problem. Okay? Accuracy is a big problem for SLBMs. Big problem for SLBMs. Okay, this accuracy is a big problem for SLBMs. So, what do you need to do? Okay, there are two ways. You can actually try to invest money to make your accuracy a lot better, or you can have much bigger bombs. So, actually, what makes SLBMs work? Okay, the second piece of technology, you need big explosions. So this will actually overcome the accuracy problem because if your bomb is big enough, you can miss by 5 to 10 kilometers. Okay, I might get my figures wrong, but that's not the point. It's just explaining concept. You can miss your target by 5 to 10 kilometers, and that won't even matter because your explosion is just so big. Okay, it will wipe out everything here. So you need big explosions, right? So okay, so this is bigger, okay, much bigger than Hiroshima. It is much bigger than Hiroshima. So that's the idea why the hydrogen bomb was developed. Okay, H bomb was developed. They want bigger and better. Of course, I mean big is a show of strength. Okay, it is a show of strength to show that the other party, hey, don't mess with me. But in terms of military doctrine, it makes these SLBMs possible, submarine launched ballistic missile possible. So there are two key technologies you need. One is the H-bomb to make this SLBM work. Second thing is that you need nuclear power, nuclear propulsion. So you can see there's a very big interplay between technology, which is this part is the technology part. This is a military technology. Okay, technology and nuclear strategy and politics, because you have this mutually assured destruction. So that's the picture of the Cold War, right? So let's just say, yeah, I mean, I'm more interested in the technology rather than the policy side, but actually policy does make it interesting as well. It gives you some context as to why these technologies were developed in the first place. Now, but the thing is that once you have these submarines, they are forever underwater. You never know where they are. They're very stealthy, and they can cause a lot of damage very quickly. Okay, so this is actually one of the most important how do you say, military arms you need for nuclear deterrence, and this will be run by the Navy, of course. Okay, so these nuclear submarines that launch ballistic missiles, these are on both sides of the Cold War. Okay, The USA will have its own fleet of nuclear submarines, and the USSR will have its own fleet of nuclear submarines. And both of them are able to launch many SLBMs, or ballistic missiles. And these three main modes of weapon delivery, nuclear weapon delivery, it forms what we call the nuclear triad. Okay. Okay, so one, we have air delivery. Okay, for one, we have air delivery. Number two, we have ICBMs. Okay, so these are missile silos. Number three, you have SLBMs. So this form the nuclear triad. It's a very important thing to know in the context of the Cold War. We want to talk about how nuclear technology has influenced policy making or security in the Cold War. You will come across these terms. So hopefully this gives you sort of a better understanding as to what's going on in the Cold War. Why do we have so many weapons to destroy ourselves many times over? Why do you need such a big bomb like the H bomb, and why nuclear submarines are so important? Okay, especially in military strategy. Okay, the other thing is that yeah, so this is from a nuclear security class that I took in during COVID. Yeah, so it's one of the more interesting classes, but there are a lot of readings. But you know, these readings do provide a very interesting story as to what was going on. And there's a lot more that has gone on, but just want to give you a flavor of what's happening in the Cold War, and at least the parts that are most interesting to me. Okay, so this you have this picture of the nuclear triad: nuclear deterrence, mutually assured destruction. This is classic nuclear security, where there are two main players over here. Of course, since then there were many other people that have come in having nuclear weapons. France, the British, India, and Pakistan now have nuclear weapons as well. So now, and of course North Korea. And so this does make the nuclear deterrence game a little bit more complicated. Yeah, so that is more modern, nuclear deterrence and nuclear security discussion. Okay, but I want to focus more on the technology side, so I will not touch on any of that. Yeah, I just want to touch about all these, why we have so many crazy nuclear weapons. Now, the thing about nuclear weapon delivery, okay, the thing about nuclear weapon delivery is that it motivates things that that have, in a sense, benefited mankind, even though that wasn't the intent of the technology development. Remember, we did talk about ballistic missiles. Okay, so the idea behind ballistic missiles is that you literally launch nuclear bombs into orbit. You launch them into space, or just a little bit below space, that space boundary, so to speak. But you want them to go into orbit, at least for a short while, because that will cause them to travel very quickly without needing fuel or anything. And then it drops out of the sky, literally using gravity, and it hits the target. Now, to get your bomb or payload up into space, you need a lot of rocket technology. Okay, rocket technology. Excuse me. You need a lot of rocket technology, right? So, rocket technology was originally intended for nuclear warheads. And so that is right. Okay, you need rocket technology. Okay, so the thing is that, okay, do you need to use rocket technology for nuclear weapons all the time? Answer is no, obviously. So one thing that has so-called benefited modern science and technology from this arms race, okay, you have a nuclear arms race. Okay, the idea is to put nuclear weapons in space. Well, you can put other stuff in space as well without nuclear weapons. So instead of just nuclear weapons, you can put satellites in space, and you can put man in space. So another very recurring event during the Cold War, a very important event, is the advent of the space race. Yeah, the space race is, of course, the race to put a man in space. I believe the Russians were there first. They put Sputnik in space, one of the first nuclear satellites. Not nuclear satellites, one of the first satellites, excuse me. One of the first satellites in space, and the cosmonauts. But the Americans were the first to put a man on the moon. If you ignore, I mean, yeah, all the conspiracy theories and all, but I'll not digress. Okay, so this actually, nuclear arms race actually moved into the space race. Now, the space race was there not just to show off that your rocket technology is good. The space race was originally there because, hey, if I can put a man in space, I can put nuclear weapons in space. So you better watch out. Okay, so there's always that connotation or threat running underneath. Yeah, so if I can put satellites in space, I'm showing off that I have the technology to do ICBMs. So don't mess around with me. So the space race isn't so simple as to, hey, you want to put satellite network, you want to have good communications and GPS. No. There was always the shadow of the nuclear arms race that was influencing the space race as well. Okay, so despite this shadow that has been cast on the space race because of the nuclear arms race, it has given us a lot of technology we have today. Okay, we have our GPS, for example, to tank. Okay, because of the space race, we actually we have lunar expeditions. Okay, so this is the man on the moon. One small step for man, one giant leap for mankind. Yes. Uh, what else do we have? Communications networks. So all your cell phones, your now even a Starlink. Okay, I believe that is by Elon Musk. And yeah, you actually have SpaceX. Okay, SpaceX does these kind of things. So they have a lot of good things for communication networks. You have telescopes, like the Hubble Space Telescope. So these are indirect beneficiaries of the nuclear arms race, which has sort of offshooted into the space race. Hubble Space Telescope, and of course, yeah, I mean there are lots of other telescopes as well. Yeah, so all these have so-called encouraged space exploration, and it has advanced science and technology, specifically with physics. So you have things like the International Space Station where they conduct experiments, so on and so forth. Okay, there's a very long list of how we have benefited from all of this arms race, even though that wasn't the intent in the first place. So you can see the whole nuclear arms race in the Cold War has influenced so much of technology development that and we are sort of reaping the benefits today. Yeah, yeah, this is a very interesting picture, a very partial, very touch and go picture of the Cold War, but hopefully it gets you a bit more interested as to how nuclear technology has influenced us today, both directly and indirectly. Okay, and most the thing I want to kind of focus on well, basically the nuclear propulsion side. These are stories of the naval reactors, and of course bomb development, which I don't really want to focus so much on that. I myself don't know what's going on at the back. We have rough ideas that we can go online and look at Wikipedia, but we shall not dwell too much on the bombs. However, it's really unavoidable to talk about Cold War nuclear technology without talking about bombs, because that is the reason why nuclear technology was developed in the first place. Okay, so we will want to talk about these eventually. But yeah, of course, we will want more storytelling. Okay, especially with nuclear propulsion, there are some uh, interesting figures like Admiral Rickover. So he actually was the father of the nuclear navy. A lot of people did not like him, though he got the job done. So it's a very controversial figure. So yeah, I will maybe we can cover that next time, but I really want to segue us into technology development soon. Okay, and then let's go into physics, which is the physics and the engineering, which is the part I'm more interested in. Okay, I'll just stop for now, and I'll see you guys next time. Bye.